Now it is time to learn more about the flowmeter technology. Please note that at times I may be using the short form OFM for the optical flowmeter. In this section, we will start with some key features and advantages of the optical flowmeter compared to other technologies. As I previously mentioned, the optical flowmeter has two parts, the downhole sensor part and the surface instrument part. The surface instrument part consists of an electro-optical module and the flow computer. The downhole part is an integrated assembly. A pressure temperature gauge and the flow sensors are integrated into one single long assembly. And if you look at from the tubing side here, like here in this picture, all we are going to see is a constant area, constant diameter, full bore system across the whole assembly. The OFM is a full bore system, as we see in this picture. Because it is full bore, there is no pressure loss. This is not the case for Venturi type of flow meters because they have some different cross-sectional areas at different locations. So there is always some sort of pressure loss with those systems. That's not the case with the optical flow meter. The OFM is a non-intrusive and non-invasive system. Let me explain what I mean with the non-intrusive and non-invasive definitions. So in a non-invasive and non-intrusive system, the sensors are typically outside the pipe, the velocity profile is not disturbed, and the sensors are not touching to the fluid going through the pipe. So, for example, if we take this case here, a non-intrusive invasive system, the sensors are outside the pipe, and they are not blocking the flow in any way. So the velocity profile is not disturbed, but the sensors are touching the fluid going through the pipe. So it's an invasive system. Here, in this case, the sensors are not touching to the fluid going through the pipe. However, as you see from the shape, locally, this sensor has already changed the shape of the pipe, and the velocity profile at that location is disturbed. So it's an intrusive system. The OFM is in the category of non-intrusive and non-invasive system, as shown here. So it's fully passive system. It is the best scenario for a measurement system. The OFM is also a bidirectional flow meter, and it has high turn-down ratio. The bidirectionality is important when we talk about producers or injectors. So in a producer, the flow going upward, and in an injector going downward. A flow meter which is bidirectional can measure the flow in any direction. The optical flow meter is a symmetric system, so it will have no preference for the direction of the flow, and it will measure the flow with the same accuracy in both directions. We cannot say the same thing for a Venturi system. I have it here for comparison. And the Venturi system is optimized for one direction. If the Venturi is installed in a producer, and if the producer is converted to an injector at a later phase, then the Venturi won't be able to measure the flow. In fact, I will provide a case history regarding this scenario where the optical flow meter in a North Sea field was initially installed in a producer, and then the producer later converted to an injector, and the flow meter performed flawlessly. Let's talk about the turn down ratio. Some people would like to call this the flow rate range. It is the ratio of the maximum flow rate to the minimum flow rate that a measurement system is capable of measuring. The higher this turn-down ratio, the better the system is. In the optical flow meter, that turn-down ratio is very high, larger than 25 typically, compared to the differential pressure gauge systems. For example, Venturi, it's a very low number. In fact, the optical flow meter does not have any limitation on the maximum flow rate. It does have a sensing limitation for the minimum flow rate. It can't measure the flow if the flow velocity is too low. We will talk about that later. The OFM can measure single phase, and it is capable of measuring multi-phase flow, two-phase or three-phase. We will talk about this in the coming sections. The OFM can also detect cross-flow between zones in a multi-zone well. In fact, the well doesn't need to be producing for the detection of cross-flow. It could be in a shut-in situation, and it is still possible for the OFM to detect the cross-flow as long as the flow rate is above the minimum threshold of the optical flow meter. The OFM provides a real-time flow measurement. It is based on a non-nuclear clean technology. It's based on turbulent flow. This is significantly different from some manufacturers which make surface flow meters based on nuclear technologies. Nuclear technology is in some areas unwanted technology, so the optical flow meter has no problems with that. The OFM is also compatible with distributed temperature sensing and distributed acoustic sensing. They use the same fiber cable. They share the same fiber cable. And in fact, the OFM is able to use a DAS instrument. It is fully compatible with DAS instruments. The technology of the OFM is applicable to any pipe size. Let me open that a little bit. So far, Weatherford has manufactured flow meters in the sizes varying between 2/3/8 and 5.5 inch. However, this technology is applicable to any size, so it depends on the request. In terms of material, there are two material options mainly. The Inconel 718 is used for high pressure applications, while the super duplex chrome is the standard version of the flow meter. The PT gauge can be ported to tubing or annulus depending on the request. However, if there is any flow measurement involved, then we always prefer to have the tubing pressure and temperature values. Sometimes the operator may also ask to have a secondary PT gauge in the annulus. That's something we can also provide. I have some tables here showing the sizes of the flow meters and some minimum flow rates, as well as some performance numbers. It is difficult to see here, but all this information is available in product technical information sheet, so I'm not going to go over them one by one. So this concludes this section of the key features and advantages of the optical flow meter compared to other technologies. Next, we will learn more about the basics, how the flow meter measures the flow.